Hello everyone. I made a slight mistake with respect to slide deck ordering closer to the end of the previous video. Please accept my apologies for that. This slide should have been covered as part of the previous lecture video. Let me quickly talk about why we are using SQLite and CS220. Not only is the software license for SQLite permissive, but the installation and use of SQLite itself is very easy. We are going to be using SQLite 3 module, which is a built-in module that comes along with Python installation. As I mentioned before, any platform that you can potentially think of is possibly using SQLite. That's because SQLite is the most famous database. I hope all of you have been able to download bus.db. Let me talk about the Madison bus route dataset. The city of Madison releases a lot of public information about bus routes within the city limits. You can find out all the stops and all the routes that are covered as part of each stop. You can also find out the daily boardings per route per stop. The bus.db database file contains two different tables. The first one is called the routes table. The routes table gives information about the URLs for each of the routes. The second table is called as the boarding table. The boarding table gives you daily boarding information for each route for a given stop. You're going to see details like stop ID, the route number, the latitude, longitude, location for that particular stop. And you're also going to see daily boardings column. Clearly, there cannot be 1.03 human beings boarding Route 27 at a given stop, which is 1163. This is the average daily boarding, so that's why you're seeing a floating point number here. Let me talk about how we can use this data shortly after doing a recap of all the modules that we have covered so far. We have learned about the math module, which gives you the value pi and other cool mathematical functions. We learned about the collection module, from which we are able to use name tuple to create a custom type. We learned about the JSON and CSV modules for processing JSON and CSV file format. Then we learned about the sys module. The most useful thing from the sys module is the sys.argv special list, which enables you to process command line arguments. Following that, we learned about the OS module, which has a lot of interesting functions about various paths. You can check whether a path exists or if a file exists, or you can also join the path to make your code portable across operating systems. We learned about the copy module, which enables us to create various levels of copies of objects. We learned about deep copy and shallow copy as part of the copy module. We also learned about the record class module, which we have to install. Record class module also enables us to create a custom type, but it enables us to create a mutable custom type, unlike the name tuple. We covered the requests and the BS4 modules as part of the topic of web. Requests enables us to send HTTP requests to get some data from a particular resource part, which is part of a remote machine. The BS4 module enables us to parse HTML file format. With respect to the topic of databases, we are going to be using two different modules. The first one is pandas. We have already covered multiple examples of pandas, series, and data frames. We are going to be using data frames a lot as part of the topic of databases. The next module which we are going to learn is the new module called SQLite 3. SQLite 3 enables you to directly access a SQLite database and do some manipulations with it. There are multiple different ways where you can use SQLite. If you have a Mac laptop, you will directly have a pre-installed tool for SQLite 3. You can try to launch that by using command space and typing SQLite 3. You can use that to explore the query language. The second option is that you can directly use the Python SQLite 3 module to interface with your database and to take the data out of it. The third way is that you can use pandas, which is going to be integrated with the Python SQLite 3 module. We're going to prefer to use the third way. As I mentioned, as part of the pandas lecture, we'll be using pandas a lot for many other topics for the rest of this semester. You're welcome to explore other options like directly using the SQLite 3 module inside Python, but for the purpose of this course, you only need to know how to interface pandas with the SQLite 3 module. Let me first talk about how you can establish a connection to your database. First of all, you need to import the SQLite 3 module. The way for you to establish a connection is by using the connect method call as part of the SQLite 3 module. You're going to say SQLite3.connect, and you have to pass as argument the name of the database file, and the return value is going to be the connection object that will be returned by the connect function. The connect function is very similar to open function for reading file data. Let me highlight the differences. When you open a file without mentioning the write mode, you're going to by default open the file in read mode. That's going to be different with respect to a connect function. Let's say that you have a typo in the database file name. You're going to create a brand new database even if you don't explicitly mention that you want to create one. That's how the SQLite 3 module is written. So you need to be really careful when it comes to typing out the database name correctly. Another thing which I want to talk about is the similarity between open and the connect function. Open function returns a file object, connect function returns a connection object, so quite similar to the open function. All right, let's talk about how to close the connection. Just like we close the file object whenever we open it, we also need to make sure that we close the database connection object by using the close function, and we should say connection.close. Let's talk about what happens in between. We are going to be using pandas module to read the SQL databases data. So I'm going to go ahead and import pandas module. We are going to use the read underscore SQL function in order to read the content from the database. The read underscore SQL function takes two arguments. The second one is the easier one. The second one is the connection that we just created using the connect function. The first one is something which is called as query, and this is going to be the question which we want to ask for that particular data. We are going to be covering a lot of examples of query over the next few lectures. Let's go through a demo in order to understand the basic queries involved with the bus database over here. I am going to use the template notebook file which I've already uploaded. Go ahead and pause the lecture video here and download the template notebook file. I'm going to import the SQLite 3 module. And then I'm also going to import pandas module. Let me also go ahead and import OS module because I'm going to need it. Let's first go through a typo example. So let's establish the connection by saying SQLite3.connect. And instead of saying bus.db, I'm going to say we have a typo in the file name by adding a lot of s's. Let me capture the return value into a variable called con. Notice that you are getting a connection. So if I now go to my list of files, you'll notice that it created a brand new database for me. That's probably not what you were going for, but let's for now stick with this brand new database that we just created. The first query that I want to introduce to you is the query which is called a select star from SQLite master. For now, don't worry about each of these keywords. I'll go through that in detail as part of the next lecture video. Let me first show you how you can run this query. So you need to say pd.read_SQL, and you can mention the query as the first argument, and the connection is going to be the second argument. So let me go ahead and run this. Notice that we are getting an empty data frame. If you try to look at the type of the return value, you can tell that it's actually returning a pandas data frame. Why are we getting an empty data frame here? That's because we created a new database accidentally because of the typo, correct? How can we make sure that we don't have such problems? We just need to assert that the particular database file already exists, correct? So I can do that. Actually, let me go ahead and close this bad connection first, and then I can go ahead and show you how to use the assert statement. So I'm going to just assert that the OS path exists for this particular file. So I'm going to say assert os.path.exists, and I'm going to pass as argument bus.db to that particular assert. And then after asserting that, I'm going to go ahead and connect to the database. So let me go ahead and run this. And now if I repeat the previous query, which is select star from SQLite master, we are going to be able to see all the table information associated with that particular database. How do we know which database we are using? The connection argument talks about which database we are using. They purposefully define this as a parameter so that you can use multiple databases, and you can comfortably just call the same read underscore SQL function because you're going to identify the database using the second parameter over here. So the read SQL function for this particular query returns a data frame. Notice that we have entries specifically about tables, and we also have certain entries about indexing. We are not going to talk any further about indexing. All that you need to know about indexing is that databases can maintain different versions of the table in order to be able to answer questions faster. Let's extract the SQL column from this data frame. Recall that you can do that by saying df of SQL. That's the syntax for extracting a column's value. If you want to extract a certain row, you'll have to use .loc and mention the row index, or .iloc and mention the row integer position. Let me actually go ahead and capture the return value into a data frame df here. That's why my df of SQL is failing. All right, let me actually iterate over each entry in the df of SQL column. We can simply do that by saying for variable name in df of SQL. Each of these is SQL code, so I'm going to use the variable code here. So I'm going to say for code in df of SQL, and let me go ahead and print code. I'm going to show you what we get out of this. All right, I used the wrong column name. There we go. So if you're taking a database course, you're going to learn the syntax for each of these SQL queries. But since we are not going to cover that much of a detail with respect to the topic of databases, I only want you to learn specific information about each of these queries. So let me switch back to my slide deck over here. I have the same output that I showed right now as part of the notebook. I'll just give you an overview of what is important. Focus on the create table keywords and then directly look at the name of the table which comes at the end of the create table line in the SQL query. So we have two tables which are boarding and routes. The next thing you need to worry about is the column name, which is given as a list of values within the parenthesis that comes after the create table line in the SQL query. You're going to have a name for each of the columns for each of the tables. The next thing that you need to worry about is the type associated with that column. These are SQL types. Those are different from Python types. The integer here is different from the int that we see in Python. The real in SQL corresponds to floating point value in Python, and the text in SQL corresponds to string type in Python. You don't really need to worry about converting between SQL types and the Python type. Pandas and SQLite automatically take care of that for you. Just be aware of the fact that different languages have different types. SQL queries are always going to end with a semicolon, but we are not going to use semicolon because pandas automatically takes care of that for you. Just know that this is the syntax for writing a SQL query. So if you were to use SQLite directly on your Mac laptop, these are the kind of queries that you'll have to use. All right, let's go back to our demo. And I just want to go through one more query before we wrap up this video. So the next query which I want to show you is how to extract the data from individual tables. So I'm going to show you how to do that for both of the tables. So we have the boarding table and the routes table. You can find that from this original data frame also. There is a table name column which is returned for the query select star from SQLite underscore master. You're always going to have to remember this query. That's going to be the first query that you always run on your database. The next query which you'll have to remember is select star from table name. Let me show you examples of that. I'm going to say pd.read SQL and I'm going to say select. Actually, let me show you an example where I have small case letters. SQL is really well built that it will accept small case letters and also a lot of additional spaces for any of the keywords. So this query will also work. So I'm going to say select star from routes as my query and connection as my connection object here. Notice that we are getting a data frame which represents the entire table. So let's take a look at the boarding table. Notice that the data frame has too many rows here. Let's say that you're interested in just retrieving the first 5 rows. You can always do that by using the head function in pandas data frame, and you can say 5 or 10 rows, whatever you're interested in. You're going to be able to do this exact same thing using a SQL query. The format for that is something which is called as limit. I'll just introduce you to an example of a limit query, and in the next video we'll talk in more detail about each of these parts of a SQL query. Let me show you how you can use the SQL language of limit to go through this same query. Instead of using the head function, I can say as part of my query, I just want to limit my number of rows to be the top 5 rows, and you're going to get the same output that you'll get with respect to using head function. All right, I'll wrap up this video here. In the next video, we'll talk in detail about each of the keywords associated with the SQL queries.